Hi, everyone, and welcome to today's Spud Smart Innovation webinar. My name is Mark Zinkowitz, and I serve as an editor for Spud Smart. And today I'm happy to be your host. Today's theme is maximizing your investment under the roof. Now, before we begin, I would just like to thank our webinar sponsors, Gorman Controls and McGowan Rice Construction. Now, just so you know, today's webinar is being recorded and it will be available on our website, spudsmart.com, after the event. Now, during the presentations, you'll likely have some questions. Please type these into the chat box at any time during the webinar, and we'll address them during the Q&A session that we'll hold at the end of the webinar. You don't have to wait till the end of the webinar to ask your question. Feel free to type it in at any time, and please just let us know which of our speakers it is directed to. Now, like I say, today's agenda is all about shrink. We're going to hear from several experts who will talk about the intricacies of shrink, what causes it, and how we can manage it better. So today we have three speakers, all of whom are with me today. Hello, gentlemen. How are you today?
Well,
good, thank you.
Great.
Good afternoon, everyone.
Good to hear. We have Scott Graham. Scott is Raw Development Agronomy Manager in Manitoba with JR Simplot. Mark Van Oostrum is Supply Manager with WD Potato Limited. And John Walsh is the operator of JR Walsh Potato Storage Consulting. Now, I know, John, you are all the way over in the eastern part of the country in New Brunswick. Scott, you and I are both here in Manitoba, and Mark, you're in Alliston, Ontario. So we've got a good cross-section in terms of geographic location. But I understand, John, you're getting snow all the way over in New Brunswick as well?
It is New Brunswick.
Yeah, we're getting it in Manitoba as well. How about you, Mark? How's your weather there?
We had a storm here the last 3 or 4 days, and it's kind of spotty. Some areas there's 3 or 4 feet, and some areas it's just a dusting. But yeah, winter arrived quick.
Yes, it did. And well, I shouldn't say that. Not here in Manitoba. It took until last month, actually November, for us to get some. And my mother-in-law has a garden and was harvesting fresh spinach from her garden in Manitoba in November, which was kind of a first. But we're going to talk about some of these climate change related type issues later, actually. We're going to welcome Mark Van Oostrum now. Mark is Supply Manager for WD Potato Limited. His career actually began on Prince Edward Island, and he is now based in Alliston, Ontario. He oversees today the production of more than 5 million hundredweight of raw chip and seed potatoes. Mark, that sounds like a lot of potatoes.
Yeah, we fill a few bins full and fill a few bags of chips. So yeah, we're a premier supplier of raw chipping potatoes. So probably every bag that you are all consuming have probably come across our desk, I hope.
I was going to say, it's kind of neat to think every time we eat potato chips, it's like you've had something to do with that. So yeah, it's fascinating. But so you're going to talk about this topic of, is September the new August? And like I said at the beginning of the webinar, totally unrelated to potatoes, but here in Manitoba, my mother-in-law was harvesting fresh spinach from her garden in November, which was unheard of. And so I would think you're going to kind of talk about this trend we're seeing where we're getting this warmer weather. So yeah, if you could try and answer this question for us, that'd be great. Is September the new August? Take it away, Mark.
Thank you. Thanks for the invitation. Yeah, so, going to try to be specific in top and not try to repeat too much what everyone's going to be sharing today. But, I'm trying to see what we can do better moving forward with the conditions that we're dealing with. So, we're going to adapt to warmer temperatures during harvest is something that we're dealing with and something that I think we're going to continue to deal with. So today, really a couple questions. Is September getting hotter, and what does that mean to us in storage, and what can everyone do as potato growers to adapt to what might be changing? So, the question comes out to, do we believe it's changing or not? 99% of climate scientists believe in climate change, but there's a lot of people that don't believe it, and it's a lot of how do you handle data and how do you report data, and things can be reported differently. So I look at it a different way, and in our own backyard. And so I kind of started to see is, ask that question. And so I took local weather data on an hourly basis from a local weather station here for the last 60 years. I think it was 560,000 different temperatures. And I just looked at the month of September and counted how many hours are below 55. I'll talk in Fahrenheit. I'll try to put in here where we're talking Celsius at the same time, but we generally talk Fahrenheit. So, we're trying to hit 55. Trend is, I'll try to get my little pointer started here. Back in the 60s and 70s, we're in 300 hours of cooling air to hit 50. And I think there's something that's changed in the last 10 years. We're running 50 to 100 hours of cooling air available in the entire month of September. And we don't always start on the first day of September. So, the trend line is down. So again, we're not always hitting 55. We in the chip market tend to harvest probably on the warmer side of the limits. And so where do we sit for the month of September as a trend line? How many hours of cooling do we have per September? And still trend line is kind of showing that it's down. We used to be, this not working here. 400 hours was normal a long time ago, and then we're 300, and now we're down in 200. And this past year, we just had just over 100 hours of cooling in the entire month. If you were trying to get 60-degree air in, so it's concerning. Let's look at it the other way, and how many hours have we seen over 70? 20 degrees Celsius. What's September look like? And trend line is increasing. It's a very noisy graph, but really spotlights the 2024, where we had over 200 hours in the month of September that were over 20. So we really felt that this year was much different than we're used to. But I would say in the last 10 years too, we can look at it where we've had a week, 3 days here, 4 or 5 days here, where we're completely shut down from harvest, almost right when we're ready to get the majority of the harvest crew going. So this one's a little bit more noisy because again, what's the question? If is September the new August? What is October the new September? This one is a little bit more noisy. It's hard to really read, and again, we tend to really have high gravity potatoes that are very susceptible to bruise. So there's a pretty clear line that once we harvest into October and we're getting nighttime temperatures in the 40s, and maybe even the daytime temperatures, we're not getting up into the 60s. It's kind of, our incidence of harvest bruise goes way up. So I don't want anyone to start thinking that, we start harvest now in October for the chip market. We're lucky in September to have Nora Olson speak to, the whole Pepsi Crow, chip supplier base, and kind of shared, the industry recommendations. I won't drain the slide, but, generally we in the chip market aren't really trying to hit down to 45 to 65. We're probably more in the 55 to 65 degree range. And history, we do sometimes push that at some farms and some areas when we're in September, and we might hit 70 degrees, not what we want to do, but sometimes we're stuck doing that. So I just wanted to talk a little bit about the data behind what does warm mean. In 2016, we conducted a storage audit with Storage Engineer and went through all of our supplier-based storages, and we kind of looked at what's their capacity. And Two things I want to really kind of look at. Respiration. Again, we talked about it. It's, it's how potatoes breathe and live. And as respiration rate goes up, temperature goes up, respiration goes up. But how do we think about those numbers when we talk about the capacity of our storages? So in the bottom left here, we have ventilation capacity. I just looked at 3 different storages. Through the audit, our average storage is about 1.1 CFM per hundredweight. But there's still a lot of storages under that at 0.8, and we have lots of new ones that are almost double, pushing close to 2 CFMs per hundredweight. And the point that you can kind of put into these calculations with your storage engineer is when we look at the hours to get from a storage that 20,000 hundredweight, it has a lot of field heat in it, over 10 million BTUs, and we got to get that field heat out, but we also need to get the respiration rate out. And on the right here, we have just a chart of, how does respiration, how many BTUs is generated. And I guess it's showing it's highly variable depending on the maturity of the potato and the variety, and temperature all plays a role. So, playing with some of those numbers and plugging them into the calculator, we end up showing that, at 3 different storages here, we have hours between 300 and 62. That's how many hours it takes, at a certain delta T. So I just kind of looked at it to say, if we had this storage this year in Ontario, it would generally take about 140 hours at the bottom, at 24-hour fan at 1.1 CFM to get down to 60. But this year we only had 110 hours in the entire month. When did we store those potatoes? It's just something to think about and something to run some scenarios through. Another one real quick is Scott had mentioned, immature potatoes and mature potatoes. In the same storage scenarios, we've got 25 million BTUs of field heat we need to get out. But an immature potato, we can say, has twice as much, respiration as a mature potato with good skin. Well, if we have a standard storage at 1.5 or 1.3 CFMs, the cooling rate is almost equal to the respiration rate. And with the ventilation capacity of 1.3, we're never really able to cool the potatoes down. We can't get the field heat out because our cooling rate is equal to our respiration rate, where, a potato that's a bit more mature, it could take up to 16 days to get this scenario where we put in hot 70-degree potatoes and we're trying to hit 55. So it's a lot of air that we're running across the potatoes. So all in all, what does that mean? What's hotter in storage mean? There's a lot of problems that can happen. And the bottom left here, we can see all the things that warm can cause, and disease probably being the one that we generally think about the most and are worried about the most, and that we see, in the storages when we're walking across the top of the pile. Pressure bruise is a significant issue in the chipping industry and in all markets, I'm sure. But we do tend to store our potatoes warmer than in any other market because of our sugar contents and the temperatures the product is cooked at. But you can see in the pictures here, we're dealing with potatoes at the bottom of the pile that have depression. What does that mean in our market? The processor complains about slicing. There's losses, going through these rubbery potatoes. The blades dull quicker. And, they tear through the potatoes instead of, a nice sharp cut. And that sucks up more oil. That's a cost. It makes a product that's not uniform in the bag. And then, of course, our typical, pressure bruise discoloration and defect is very egregious. And just one of those chips that might get by into a bag is a very high correlation that a consumer will phone and complain. And when we talk more and more on weekly basis is peel flakes. So that peel that's on that rubbery potato, breaks apart in the process and it deposits on the chips, and it just looks a little bit salt and peppery. And so consumers are not liking that as well. So that one specific issue, is very related to heat. And so what kind of strategies can we do to manage that, knowing that we're, continuing to see warmer Septembers? So, variety plays a big role in that. How do we get our varieties to be ready and mature and with good skin? The nature of our market, the varieties we don't want to peel them a lot at the plant, so our varieties tend to have fairly thin skins. And how do we set those things up? So, and at the same time, how do we manage disease? And so, I think you look at where you can on your farm, looking at the disease, risk to your varieties. How do you play that into your fields, and how do you end up, making your harvest, successful from planting to the start of top kill? What day does that look like? And look at the calendar based on the length of season of your varieties. So, some varieties can handle the heat and some can't. And if you're going to be in that window that you have to, it might strike you to start changing, on a bit of your acres. If we look at the storage design and capacity, I would say, in the last 10 years, the amount of cooling that we've put into chip storage has been fairly dramatic. Nearly every one of our suppliers has a bin. But I think, after going through this year, I think we probably need more cooling and higher cooling capacity. And so we have all kinds of different shapes and sizes, and there's a lot of permanent installations, and that will help us work through the cooling period that we need to get through September. You can also look at your ventilation itself. Are we ready for a renovation of current buildings, increasing fan size and capacity so that we can actually do more work in the fewer hours that we might have? And then again, looking with your storage engineer, looking at an audit, what really, scenarios you can go through and make adjustments in a plan right from the get-go of, moving forward. If we look at planting date, it's a hard one to really tackle when you get stuck into a wet spring or a cold spring. But, is it time to think about planter capacity? 4 row, 6 row, 8 and 12 and 10, they're stuck in between there, or another planting crew. It just gives you more time to get more of the crop ready, so that we're not chasing skin set. And, in some cases we're, causing early top kill, on green vines that, again, doesn't set itself up for good maturity. So, and then you can look at fertility programs. What can we do, with the varieties that we tend to have in the chip market are mostly longer term varieties with lower skin set, poorer skin set. And, maybe we take a portion of our acres and, we kind of, stress them a little bit, under fertilize them, put them on some of the weaker ground that we can, get a bigger portion of our acres more mature, and tougher skin to handle that warmer harvest. Adjusting the harvest at the other end, what can we do? And, this was, really put into place this year in Ontario for sure, is, be ready and have your crew ready to start earlier in the morning. And are you set up, with lighting and safety to manage that? Getting those extra couple hours in the morning did keep us moving forward in a time in the last few, last 5-10 years where we completely shut down. We made adjustments and prepared the harvest crew to be ready to not start at 7, and we might start at 4 or 5 or 6. What other ideas are there? Is it in the need that you might think about a second or even third harvest crew and equipment? Do you talk about 2 different shifts? When the days are ideal, you're getting twice as much done. And then there's other thoughts, about, there is already that, capacity maybe in your neighborhood. Do you work with your growers? Not every grower starts on the exact same day based on their, own conditions and fields. Do you grab your neighbor who hasn't started this week and you borrow them and their equipment for 3 or 4 days, and, and once you're done, you help them at the tail end, and that might help, bridge those gaps a little bit. And again, I want to really stress that you really look at your pulp temperatures and your guardrails and your set points, and inform all your team normal for us, we generally would go 45 to 68. Optimal, I would say, is 52 to 66, and we know that range is not you're not going to get that every single day. But I really think we need to watch the max temperature, and we watch the max temperature in the field, not so much at the bin. And even with the disease risk we have had here in Ontario the last couple of years, over 60, the incidence of disease is significant. So pretty hard guardrails that you'd have to set to be more successful. Fungicides, make sure that the kitchen sink is thrown at it with the risky varieties that we have in the portfolio. Really good fungicides out there, and working really good on tuber protection with late blight and pink rot out there. More and more post-harvest fungicide being used. It's hard to make that decision at the time. Typically, we're not seeing, we're not going to see the fusarium when we put them in the bin. But it might be something that, knowing the conditions that we're harvesting in year out is it becomes a tool in a toolbox that just becomes a standard practice. So think about that. Pre-harvest irrigation, of course, not very many people have that ability, but where we do, it is very significant in reducing pulp temperature. Lots of factors that come up with this range, but you can get anywhere between 4 to 10 degree temperature reduction in the pulp temperature in a sandy soil. Applying a 1/4 inch of irrigation, you can have a significant cooling effect. And then, of course, the bruise reduction just by being able the ability to carry more dirt. And this is probably the one we're probably most interested in, and we see box storage giving every grower in every scenario that little bit of flexibility to minimize the pressure bruise risk that inevitably every grower may experience in a condition of a variety and harvest day that year in, year out, we'll have a storage in a bin and a grower that will have an issue with this, and box storage might help us that way. So, we cannot always cooperate, with Mother Nature in the decisions that we make. If we can think about the idea of box storage in some capacity in a few farms, we will, help secure our market in that May to July window. We're going to reduce the variance between load to load because of that pressure bruise, reduction or potential elimination. We have a lot of loads that we load in the morning that get delivered, not as fast as we load them. So your first load might load and deliver in, 4 to 8 hours. Your last load you load might not be, fried for 24 to 36 hours. They left the farm looking all the same, but they're going to look completely different when they get done, finished processing. There is a big why not, I guess, to this whole box storage idea. We have several, commercial size lots that will really do some deep dive into this. The cost is very, is one of the worries behind the idea of box storage in the chip market. And what are the benefits? A few years ago, we did some trials and box storage potatoes in July, from the quality data that we get back, looked exactly the same as the bulk storage potatoes. They were both 10 defect. But at the plant, there's a whole bunch of other quality attributes that we're not really talking about, that doesn't come in on the grade sheet. And so what did the factory see? They were like the box storage potatoes, even though they looked, from a consumer appearance of 10 defect, the processing plant was looking at July storage potatoes like they were brand new potatoes. They were firm. They peeled perfectly. There was no depressions. The skin came off. There was lower waste. less oily appearance. The oil uptake was significantly different than the bulk storage. So supply resiliency, we're going to look at all those attributes, come next year on commercial scale and see what value that also is for the processor outside of what our typical quality standards would be. So I guess kind of the takeaway is, data is suggesting that it's getting hotter and there's less optimal harvest days. Is digging later in October the option? And I'd be cautious of that one. In our market, we do tend to appreciate digging warmer for harvest brews. But I think we need to look at management and understanding, our storage limitations. And if anybody's thinking about, building a new storage, I think a box storage should be, on your list of things to look at, looking out at the box and look into the box, I guess.
Thank you so much, Mark. That was fascinating. And like I said, it sort of sets the stage even more for us for our final talk here. They're going to hear from John in a moment. So thank you so much, Mark. Don't go anywhere. Hang on for our Q&A. Welcome, John. Good to see you. Now, like I say, you are the operator of J.R. Walsh Potato Storage Consulting, and you're actually coming to us from New Brunswick today. And you started J.R. Walsh Potato Storage Consulting after a long career with McCain Foods, which you joined in 1988. And you started your consulting business in July of 2022. So I think it's safe to say you must have a real passion for potatoes to want to continue to do this even in retirement.
Oh, yeah. Well, I like to keep busy, and this is a very fascinating industry to be a part of. So.
It is indeed. Now, you're going to be talking about managing shrink and storage, and everything we've heard up until now has kind of been building to this, especially with what Mark was just telling us in regards to box storage. So I will turn the floor over to you, John. Take it away.
Well, thank you, Mark, and thank you to the sponsors, and also thank you to the previous speakers because they made my job easier. They've talked about a lot of things I'm going to be talking about in this discussion, so I may gloss over them a little bit to maybe save us a little bit of time. We'll see what happens. Now, the first thing I want to do is define shrink. And shrink's kind of a number that maybe not as accurate as I'd like it to be, but the simplest way to express it is it's the difference between the total weight of potatoes put into storage and the total weight of potatoes marketed out of the storage. It's maybe a little more complicated than that, but that's really what it's all about. So I want to look at the types of shrink, the things that will contribute to the weight loss you see in storage. And the first part, I call it natural shrink. It's the biological process the potato goes through already. And Scott sort of introduced that, so I'll go a little further perhaps. So that first one, of course, is respiration. And we already know that potatoes breathe and they are alive and they stay alive until they're cooked or processed. However, you see that you've got oxygen going in and CO2 going out, and if that CO2 builds up and heat builds up along with that process, it can create problems in storage. Most of that takes place through what we call the lenticels, which are the breathing pores on the potatoes, and they represent about 2 to 3% of the surface area of the potato. An immature potato, there will be some movement through the skin, but once they're set, it's all through the lenticels. Oops. Now, Scott mentioned the temperatures involved, and you can see that the lowest rates of respiration are between 7 and 10 degrees Celsius, about 45 to 50 degrees Fahrenheit, and it goes up below that and goes up above that. The other thing that's important is that the health of the tuber. The harvest is very hard on potatoes. You've got bruising, you've got bumping, you've got cutting. The potatoes is leaving its natural environment and moving to a storage, which is not a natural environment. And potatoes wants to fix the damage that happens during the harvest, and it does that by respiring more because that's how it gets its energy. It breaks down starch to produce the energy that the potato needs to fix those problems. So let's keep that in mind. Now, you might think that you want them down to 7.2 as quick as you can, and you've already heard that we talk about a curing temperature. And this is a study done by one of Nora's students, where she took 3 varieties, Russet Burbank Ranger, Russet Clearwater Russet, and stored them at 7.2, 8.12, 8, and 18.3. That's actually the curing temperature. They were cured for 2 weeks at that temperature, then either ramped up or ramped down to 8.9 or 8.8, something around 48 degrees Fahrenheit. And the first thing you notice is that the potatoes with the highest temperature curing had the most weight loss. And that's largely due to increased respiration of those higher temperatures, as well as increased transpiration, which I'll talk about in a moment. Next worst was 7.2, and better was 12.8, especially for these other two varieties, Ranger and Clearwater. And what's going on there is that they're cured better. And that curing is so important that it can actually reduce the type of shrink you see just from respiration. Next one is transpiration, or the evaporation of water from the tubers. And water leaves the tuber naturally, and it leaves through the lenticels, but it also leaves through the skin. The water molecule is small enough that it can go through the skin. Now, set skin, mature skin is a little bit more resistant to that water loss through it, but they're still going to get water loss through it. And what drives water loss is something called vapor pressure deficit. Now, vapor pressure is the amount of pressure in the air, or air pressure, due to water. And it's a relatively small number, but it's yet significant for the potato. So we always assume that the potato tuber is at 100%. It's a little bag of water. It's 80% water. And interestingly enough, excluding rot, 80% of the water loss or the weight loss of tubers through the storage season is through evaporation. Respiration makes up the other 20%. And then again, of course, we'll talk about rot in a minute. Now, as I said, what drives this is called the vapor pressure deficit. So everything wants to go from a concentration that is high to a concentration that's lower. So here, if you look at this example here, here's the tuber at 100%. In this case, it's 45 degrees. And the humidity is 95%. There's a difference there. That vapor pressure deficit is the difference in this number and this number, and it's 0.015. If you want to know the units, is millimeters of mercury, which is how you measure air pressure. If you drop the humidity to 85%, that vapor pressure deficit goes to 0.44, 3 times as much. So in other words, big surprise, drier air, 85% humidity air, has more drying power than 95% air. In addition, there's also the temperature effect. Again, if you look at the difference of vapor pressure deficit at 7.2 degrees, if you go to 18.3 or 65, that vapor pressure deficit is a double, which means, as you might expect, that warm air has more drying power than cool air. And that's going to come back here in a little later when I talk about something else. So basically, both temperature and humidity are important. Not a big surprise there. And of course, there's also the skin set. Now, what I'm showing here is a tuber that's basically been cut. This was an immature tuber. We sort of pushed it back with a thumb. But just imagine this is a mature tuber and someone cut that. The difference in weight loss from where the skin is intact to where the skin is removed is very significant. 300 to 500 times higher. That's a huge number. It's basically like putting a tap in the potato and turning it on and sucking the water right out of it. Now, the potato doesn't like that, and it's going to try to fix that as quickly as it can. And what it does is it deposits some waxes onto the area that's cut, and very quickly cuts that down, reduces that water loss from the tuber. And within 24 hours, that's dropped to maybe not as low as 0.001, like I'm showing here. Sorry, I guess you can't see that, but with a 0.001%. But within 24 hours, that might be 0.02, 0.03, and it'll probably always be a little higher than where the skin is intact, but it improves quite a bit. So the main thing is that early in the harvest season, after the potatoes have been harvested, the skin is not finished. You've got these wounds. Those are all areas that water is going to leave the tuber, and that's important. So we sort of assume that with 5% skinning, you might get an extra 0.5% shrink. It might be a little less, a little more. If that's 10%, you can probably double that. So that becomes very significant over time. So obviously the main thing is try to reduce damage as much as possible during the harvest. Now, obviously curing is important, and we've already heard mention of the curing period. I usually recommend a little higher temperature, and this study was the same one I showed a little earlier by the graduate student that Nora had. And if you look at the 5-day column there and the different temperatures, you can see that basically at higher temperatures, you get more cells and you also get more suberization. So by day 20, you can see that there are a lot more cells. They're now well suberized, and that's what you want. And basically, I've sort of come to the point where really what you want is somewhere around 55 to 60 degrees, or sorry, 55 to 56 or 57 degrees for the ideal curing temperature. You heard lower numbers when Scott was talking. Other areas have slightly different requirements. Washington State usually gets by with, 50 degrees because their potatoes are mature when they're harvested. So the other advantage of this temperature is that it actually helps with removing sugars. Most of those are converted back to starch, but some of it is respired away. And then there's sprouting. Now, this potato is very sprouted, and actually what you might typically see in storage is you only have one sprout out of the eye end of the tuber, but as you go along, the other eye will start sprouting. What's important here is that sprouting causes weight loss in two ways. First of all, it pulls water out of the tuber. Those sprouts need to grow, and they take water and carbohydrate from the tuber, and they're also respiring more heavily. So you're getting a lot of respiration, you're getting a lot of movement out of the potato, and they'll shrivel up quite quickly. The other thing, of course, is that when those sprouts are removed before sale or processing, you lose weight right there. So as you might expect, good sprout control is essential, and I think most growers do a really good job of this. There's all kinds of alternatives out there. We still have CIPC, which incidentally Europe doesn't. Whether we lose it or not depends on a number of factors, but certainly good sprout control is essential to minimize shrink in storage. And then there's rot and rot potential. And rot is the killer. Anytime you hear about big losses in storage, they're almost always due to rot. And I will also add that it doesn't seem to matter what starts a rot in storage, soft rot takes over, and that's what will do the most damage. And I have literally seen potatoes flowing out the door from a bad rot situation. So obviously it's not something we want to have happen. And what I think is important is that what kind of rot potential you're going to have when you're putting your potatoes into storage. Obviously, potatoes that look like this are going to be relatively easy to store, and you're probably not dealing with a lot of rot. On the other hand, if you've got potatoes that look like this, yeah, you've got some issues going on. You've got a rotten tuber there, and that rotten tuber, if it breaks down before it's dried out, it's going to wet the potatoes below them. They're going to get wet, and that's how rot spread. You can also see that the skin set is not ideal on these potatoes, and therefore you're going to get more shrink just from the fact that they're not fully healed at the beginning of the storage season. They take time to fix that. That takes energy, et cetera, et cetera. So what we need is some way to estimate the rot potential, and actually Scott sort of hinted at that earlier. What you want to do is, this is actually a system we developed in McCain Foods, that we flag issues. And if you look at that first column under situation, you can see all the things you need to flag. If you have late blight in the field or going into storage, if you've got heavy rains and there's wet spots in your field, if you've got rotten tubers in the field earlier on, even before harvest, if you've got high temperatures at harvest, frost or frost damage, if you're seeing rot as you fill your storage, if you have a wet period, or if you have a wet harvest, the crop's immature, or you have no cooling air available, as Mark was talking about, those all contribute to rot situations in storage. So what I'd like to do is, if anything happens more than 3 weeks prior to harvest, we would put one flag up for each of those. And those flags stay up. So for example, if you saw some late blight in the field in July or August, and then it disappeared, you think, maybe I haven't got a problem. The potato doesn't forget. So leave that flag up. If you have those same issues 3 weeks prior to harvest or during harvest, you put two flags up. And I'm going to talk about how to deal with that in a minute. Some things to keep in mind. Obviously, every year is different, but even the beginning of the harvest to the end of harvest can be very different. You can have a nice warm period, and then all of a sudden you get some rain, it stops you, and then it cools off, and all of a sudden you might be putting cooler potatoes and wetter potatoes into a storage that's full of dry, warm potatoes, and that can be a problem. Also, for every rotten tuber you see in the field or at harvest, there might be one or two that you don't see. Also, if potatoes are affected during harvest, those symptoms might not develop for 2 or 3 weeks. And that means that you think you're putting very good potatoes into your storage, and all of a sudden issues crop up. So again, you need some way to estimate the potential. Now, it'd be nice if you could detect rot before you could smell it or see water in the ducts. I'm working with a company called Cellar Insights. It's looking at a way that might enable us to do that, and I'll talk about that a little later. And then, of course, there's harvest and handling damage. I've already mentioned that Harvest is hard on potatoes. You're taking the potato from its natural environment and you're putting it somewhere else. They're bumped along the way. They might be cut. If you've got rocks, they cause damage. You can see that potatoes are dropping out and they're also being picked out by people. If you're not weighing loads in, then basically the harvest and handling effects really only impact shrink when you're emptying the storage, but they're still happening. And so anything you can do to minimize damage to the potatoes during the harvest will help you in storage and help you minimize shrink in storage. All right, so how do you manage all this? Well, I use something like, I call it the traffic light model, and obviously green is better than red. So let's look at the green situation. So there's that picture again. Here's a situation where you have no flags up. The potatoes have gone into the storage, cool and dry. There's fewer or no disease tubers noticed. Dry throughout the harvest. Could be a well-cured crop. It doesn't have to be. So there's some flexibility in here. But basically, you're looking at a near ideal situation, or one that doesn't make you worried that you're going to deal with rot in storage. So how would you manage that? Well, the first thing is turn the humidity on right from the beginning, even as you're filling the storage, if you can do it. Now, if you have ducts running the length of the storage, that's kind of tricky. But if you have ducts running across the back of the storage to the front, you can even turn the fans on at night with a partially filled storage and provide the conditions that are ideal for the potato. You want the humidity high, 95 to 97. You want the set temperature in that 55 to 57 degree range. That's the ideal for curing, and it also helps with dealing with sugars as well. So that's one of the reasons I like it. You can go a little cooler if it makes sense to you. I have no objection to that. You don't need a lot of air. Thing about potatoes is when they need air, they need lots of air. When they don't need it, they don't need a lot of air. If you have a doubled system, and this is where you sized everything for 1.5 CFM per hundredweight, but you put in double the fans, well, then you can run them at half speed or less, and you save energy that way. But if you need air, you have it available to you. And again, you want to cure 55 to 57 to 2 to 3 weeks, and then start cooling, ramping down, as Scott mentioned. And if everything is ideal, how much shrink might you see? Well, maybe only 0.5% the first day, 1 to 1.5% the first month. Again, that first month is always going to be where you're going to get your most shrink because there's a lot of things going on, high rates of respiration, they not be fully set skin, etc. And you might only see maybe 0.4% a month after that. So your total in 6 months might only be 4 to 4.5%. And that actually may be high for some areas. I know certain growers in Washington State might only see, 3.5 or even 3%. So when everything's perfect, you can have very good conditions and get your minimum shrink. Now, condition yellow. Now, where I am in New Brunswick, I would say most growers deal with a condition yellow, 5 out of 6 years or 6 out of 7 years, something like that. So they're always dealing with something. And here you're talking about maybe 1 or 3 flags during the growing season from those things I've listed. The weather may be uneven during the harvest. It may be a little wet, it may be a little dry. There may be some frost at the end of harvest. You might be seeing the odd rotten tuber, or you might be seeing more than the odd rotten tuber. You may have a variety that's more susceptible to rot. We always knew that Sheppardy was more susceptible than Russell Burbank, for example. And if potatoes are skinned or bruised, or you have poor skin set, that's obviously something to be worried about. If you're applying chemicals such as fungicides or sprout inhibitors, not so much sprout inhibitors, but fungicides, they often go wet. You want to make sure that's dried up as well. In terms of managing it, you've got to plan for some drying. And to dry, that may mean turning your humidifier down if you have that ability, or maybe if you have a humidicil, you may have to turn it off for a period. Obviously, the amount of time you need will depend on how many issues you're dealing with. I talk about more than 3 flags. There was one year where I met a grower who had 12 flags, and he had some issues to deal with. You may have to use the fans at higher speeds. Maximum speed may be necessary. If rot is present and persists, then you may have to start looking at lowering the humidity or just leaving the humidifier off. Drop it to 90 to 92% or 85 to 80% if necessary. If the rot persists, you may have to start cooling. And you may get down to the holding temperature. You may even go a little lower if you think you might lose them. You need to be aware of the outside humidity. If it's raining outside or there's a high humidity, then you might as well turn your humidifiers off during that kind of weather. And of course, we've already heard about using heaters above the pile, so I won't say much more about that. In terms of what kind of loss you might see, now you're looking at maybe 1 to 1.5% the first day. at 2 to 3% the first month, maybe 0.5% to 0.6% a month after that. So all of a sudden that 4 to 5%, 4 to 4.5% I mentioned earlier is up to 5%, maybe 7.5% over 6 months. And these numbers are actually based on my experience. I had oversight of 1 million hundredweight potatoes and McCains around the world, and different areas had different numbers. And these were the kind of numbers where you had issues. That's the kind of numbers you'd see. And then you got red. Now here you're dealing with a mess, and you're really not expecting to keep those potatoes very long. You've probably got a lot more than 3 flags. The potatoes are coming in wet and dirty or even muddy. You've seen a lot of rotten tubers. You're trying to pick them out. You may have had a lot late season frost. Potatoes are skinned or bruised. I mean, all the things that are bad more or less happened. And to manage something like this, you got to have maximum fan speed, as much air as you can put. You might even try to find extra air if you can. You want to set your humidity lower than 90%. I don't usually recommend going below 80% because some funky things tend to happen in the pile. You can actually have the top of the pile cooler than the bottom. Now, some people don't worry about that. It kind of bothers me. Use a heater above the pile to bring in more outside air to get those humidities lower. Again, if the rot persists, you want to start cooling right away, and you're going to be ventilating to the max, and you might have to cool quickly to get them down to a temperature that'll help control the rots. And if you can keep them that long, you might be ventilating continuously with dry air for up to 2 months or more. If it's that bad, I mean, we're 4 to 5%. That looks like a low number, but I'm talking maybe that's a month. If you can keep them 2 months, that might be double that. And then the question mark is, if you can't manage it, you're going to be getting them out there and you may be dumping them, which is obviously something you don't want to do. So obviously there's some flexibility in this, but the main thing is that make sure you're aware of what you're dealing with in your storage. Make sure you know what kind of rot issues you have and other issues you have, and that helps you manage the storage. Now, something very quickly on how you can measure shrink. It's actually very difficult to do, and I'm actually working with Cellar Insights to see what we can learn about that. And there is no perfect system. Ideally, if you can weigh all the loads in and out, that's the best system, but even it's not perfect. And it's not practical for most farmers. They just don't have the facility to weigh those potatoes. Another option is weighed bags of potatoes, either on top of the pile so you can measure them regularly, or you can put them in the pile as you're filling the storage, and then they'll get weighed when they go in and they'll get weighed when they come out, and you get an idea of what your shrink is. Now, if you get rotten tubers in any of these bags, that affects your results, but that may be an indication of how much rot you're dealing with. So it may not be the worst thing to happen. But, and the more bags, the better, obviously. But of course, that means a lot of work. And most growers are extremely busy at harvest, and most growers really don't have the time for that. So I'm working with Cellar Insights on this. And what they've done is they put a sensor in that measures the height of the pile. So once you go in, you know what the height of the pile is. And then this is measured continuously. So you can literally follow the dropping of the pile continuously. Now, is it an exact measure of shrink? Sorry, excuse me, no, because there may be settling. Also, if you reach a certain point, if there's enough shrink, the potatoes will start to compress. That may cause pressure roots, but also lowers the pile. We're working on to see what we can do to factor those things in so that when we get these measurements, they can tell us what we need to know. And Mark, I'm just going to turn it back to you. I know that we've run a little long, so I don't want to go any further. So turn it back to you.
No, that was great. Thank you so much, John. I will invite Scott and Mark back to the stage because we have some questions from the audience. So we have time for a little Q&A now. Again, if you have a question, please type it into the chat box. I have a question about fan speed. What is the lowest speed you will run your fans on, assuming you can maintain your 1 degree top to bottom of the pile? I'm thinking that's maybe probably directed at John, but yeah, any of you feel free to weigh in. What's the lowest speed you advise running your fans on, assuming you can maintain your 1 degree top to bottom of the pile?
Yeah, I can answer that quickly. Typically, my experience, the slowest you're going to be is about 50% speed. Now, if you have one of these double systems I talk about where you've got twice the capacity for the duct sizes. You can actually go down to 25%, but that's relatively rare. So I think 50% is probably about the slowest you're going to run them. So.
I have a request here. Sorry, somebody requested wanting to see the condition green slide again. So I'm just going to go back here. And while I'm doing that, I have another question. As a table stock grower, is there any logic to trying to add humidity in the pile by running humidifiers at very low fan speeds?
Okay. Well, I think you need to have the humidifier tied to the airflow. You don't want to put too much water in the air, because it's just a waste of water. So it may be that you might have to close, if you're running at slower fan speeds, you may need to shut some of the nozzles off if you're spraying it in. A little trickier with the humidicell, but the humidicell is also built so that if you slow the fans down, you'll slow the humidification down. So I hope that answers the question.
Question for Mark. Is there any preferred ventilation system or air distribution system for box storage? What do you think, Mark?
I would say what we're looking at is probably, I don't want to pick any one brand, but European ventilation companies are probably pushing more into our area. Kind of ones we've looked at so far are sort of plug and play, where it's kind of throwing the air. It's a small unit that fits in a container, and you basically just cut a hole in the wall, and it's throwing air across the top of the boxes and pulling it from the back. I guess our learning so far is, generally higher is better, building higher and shorter distances, as opposed to trying to, throw air to a really long building. But I don't really want to say any brands that we would prefer. I'd say that's where more of the experience in the box storage is why growers are heading that way.
Mm-hmm. Question regarding harvesting speed. When harvesting speed is critical, will storing in boxes be slow in the system?
Yeah, that's probably one of the biggest concerns. So capacity is a big thing. So, cost and capacity is huge. So it depends on how much you want it to build, what big part of what percentage of your storage would you want in the box. It plays a big role in your filling capacity. So can you put away 50,000 hundredweight in boxes? No problem. You just need more, infrastructure.
Yeah.
And so how have we started? We kind of, try to fill out, the variety that you're putting in bulk storage at the same time as you're doing box storage. And that's probably the best way to get started and get your feet wet in it. Divvy up some trucks that goes to a small box line at the same time you're doing bulk, and then future would be fill a box storage with higher capacity.
Scott, how can a grower utilize sugar information to make better storage temperature and fry color decisions?
Yeah, thank you. Well, they can start pre-harvest sugar samples. So leading up to harvest, you can take 2 to 3 rounds of sugar samples every 2 weeks. And that can tell you the maturity of those fields. And you can try to group those fields together at harvest time. Now, I understand some large farms, you're not going to run 15 or 20 miles from one side of your operation to the other. But it definitely gives you an idea on where the sugars are, at harvest. And then, after the invertase 2-3 weeks, I call it the harvest hangover, where the sugars kind of go wacky. You can start, testing those sugars and fry color samples. And then once you're lower, like down to 1 or whatever, 1 milligram per gram, whatever you're comfortable with, you can, start to reduce your storage temperature 0.4 degrees a day, or however you feel. And generally every 2 to 3 weeks until your holding temperature, you can, take those sugar samples to make sure that everything is going good. And then if you do have to go slower or stop, that allows you to figure that out.
I have a question about temperature fluctuations. Can any of you speak to the difference between potato pulp temperature fluctuations in the field versus the pile? We are always monitoring to make sure that cooling and storage is not too fast. However, in the field, a potato must fluctuate dramatically from day to day, or must fluctuate dramatically from day to night. Is this also a factor of concern?
I don't think so. I guess basically the potato's used to these things, so it's going to grow as it normally does. I've never seen the fluctuations during the growing season had a big impact on what you're going to do in storage in terms of managing the storage.
What is the ideal static pressure in storage, and what is the best way to measure static pressure in a system?
It's very difficult. Or sorry, guys, I'm butting in here, but it's very difficult to measure. What most ventilation companies do is they size their fans on a static pressure of 1.5 or 1.5, whatever the unit is. I can't quite remember at the moment. Whereas in storage is more typically like 0.5 or something like that. So they're ensuring that you always have enough air. In terms of what's ideal, I think that really is up to the people who design your ventilation systems. And to say it's not an easy thing to measure. I don't think any grower could practically hope to measure static pressure on a regular basis.
Yeah. Mark, being with Spud Smart magazine, I'm always writing a lot about varieties of potatoes. We love talking about new varieties and things. And a question regarding varieties, can you provide examples of chipping varieties that are particularly well suited to warmer harvest conditions, considering the risks?
Yeah, for sure. So I guess I would point out two that we've looked at just recently that have come out of universities. Would be Mackinac and Lady Liberty. Like when they were challenged with sustainable varieties and grower friendly varieties, both of these varieties have very good disease tolerance, not only from a late blight standpoint, but just soft rots in general. They've held up really well the last 2 years that have been extremely wet for us. Brings along that they can handle those conditions, and they have very good skin set to them. There are other reasons. One that what we would have done the last couple of years is the variety Juanita, and it gets good skin set, but it also is not really susceptible to storage rots. It's an early shipping variety too that transitions well. If there was an issue, it doesn't have that kind of hangover. So we have really good color. That doesn't have that stem end defect that might appear in some other varieties. So those three are kind of ones that you could switch to if you were, and even to the point where in your top kill schedule, harvest schedule, take the risk on these varieties. Even if they were skinning, take that variety over the variety that is thin skinned and susceptible. Like pick on Lamoka being very, very susceptible to soft rots and storage disease. So even if it had a better skin set, if it was warm, go dig your Juanitas, even if they're not ready from a days to harvest.
Thanks, Mark. The questions keep coming. I love this. Please, if you have a question, type it into the chat box. What is the ideal static pressure in storage, and what is the best way to measure static pressure? Oh, yeah, I think I asked you that one already. Sorry, I'm reading the wrong one. It's very interesting, the variance of mature versus immature potatoes and the heat generated from respiration going into storage. Is this value estimated, or can it be determined from pre-harvest sampling?
I don't think so.
Yeah.
I think that's pretty. You're talking measuring CO2 output or something like that. I mean, theoretically, maybe you could use a carbon dioxide detector, but I don't really think so. I think no, that's not something that's easily measured.
Yeah. I think it's good to put into the calculator and just kind of give yourself an idea of, this is the best case scenario of a really mature potato, and I know it's a really low. From history, you don't have a lot of CO2 in storage with that variety would be a good one, and then plug in something that you'd say is really immature and then see how that would affect your storage.
Yeah. Well, obviously, if you got poor skin set or they're badly skinned, I mean, they're going to be respiring more. You just know that. And if they're harvested under warm conditions, you know that's going to be a factor. So it's really the conditions that create the problems that you need to be aware of. So.
In regards to CO2, what is the importance, if at all, needed for CO2 monitoring for seed potato storage?
Well, that's an interesting question. And one of my colleagues, Gary Hawkins, his whole life was seed. And we both believe that there is an influence. You still don't want high CO2 in the seed storages, but we don't have anything to back that up with. There's no data that I know of that says high CO2 hurts seed potatoes, but I still wouldn't want it. That's where maybe I can put that. Maybe Spud, Mark have other opinions on that.
Yeah, I agree. It's nothing that we're measuring generally commercially, but I agree that it's something that we should think about.
I think the more important thing is that if you can provide fresh air to the potatoes, and that means the CO2 is going to be gone, that's good for the potatoes.
Mm-hmm. Yeah.
Can you speak to the trade-off of using refrigeration in the fall in order to maintain pile temperature in warm outside conditions against weight loss from coolers supplying very dry air?
Yeah, that's, I think, is actually a bit of a misconception. The way most refrigeration systems and potato storages are designed, they only refrigerate a portion of the air and they cool that down quite a bit. But it's mixed in with the other 2/3 of the air that's coming off the top of the pile. And when you look at what the humidity is in the plenum, it's actually not that dry. So yeah, I don't think refrigeration actually causes a lot of drying in storage, the way that it's designed for potato storages.
What about temperature? Can air conditioning bring down pile temperature during harvest?
Well, that's if you have enough refrigeration, yes, it can. I think most potato storages, certainly in the east anyways, they don't have that kind of capacity to do that. I think what they can do is maintain the temperature during the day and then take advantage of any cooling air at night to at least not have it warm up. Is the way I would put it. Again,
yeah, I think we've really noticed the last couple of years where we're, at least when we stop at the end of the day, we're getting some, air transfer, getting some oxygen into the pile that generally we would have no ability to bring in a lot of fresh air, or we're purging with hot air to get some oxygen to flush the CO2. So we're probably with the different shapes and sizes of refrigeration units, we're maintaining as opposed to increasing the pile. And without the air conditioning, the pile temperature will continue to warm up after you stop that day without refrigeration. So.
A couple more questions before we sign off for the day. If a new storage is being built, what new technologies or monitors are available to generate data to better manage storage? Anybody want to take a crack?
Well, the ventilation company, they're going to give you most of that information. To give a little plug to Seller Insights, they're working on making available the ability to look at your phone and see what the CO2 temperature, et cetera, in your storage is. They may even start at some point down the road, may be able to introduce the ability to detect gases that are indicative of rotting. And that would be a great thing to have. But really, if you go to the ventilation company, they'll tell you what the technology is that you need.
Scott, I want to give you the final word here today before we sign off. Do you have any advice on pre-harvest storage preparation?
You got to make sure it's clean, disinfected. You don't want to carry the previous year's problem over to the next. So get the dirt out, get all those tubers out, vines, any type of debris, and wash it down, and then use a disinfectant, PAA, parasitic acid. Very good to use.
And if I can calibrate the ventilation system,
yes,
sensors,
ventilation system, sensors, temperature sensors, absolutely. Make sure your humidity is ready to go.
Yep.
Wet bulb, dry bulb, clean your humidity sensors.
And Scott, what about advice on storage cleaning and sanitation?
remove that debris, the vines, the tubers, and dirt, and steam it down, and then finish it off with a disinfectant, PAA, parasitic acid.
And Scott, finally, how can one mitigate? You're talking about pressure brews earlier. How can one mitigate pressure brews?
If your pile is healthy, start the humidity right off the bat at 95+%, and keep it going. Don't if you see the trucks heading to your neighbors, that doesn't mean you go and shut your humidity off. Just manage your humidity as per your storage and your pile.
Okay, well, thank you, everyone. This has been a great webinar. I want to thank everyone for their time today. That's all the time we have. I want to thank our sponsors once again, Gorman Controls and McGowan Rice Construction, for their support. Like I said, this webinar was recorded and will be available on spudsmart.com in the coming hours. So please feel free, our audience, you can go to our website, you can watch the webinar, share it with whoever you like. Please help get the word out. I want to thank our speakers today, Scott and Mark and John, for your time today. This was great. And thank you to our audience for spending your lunch hour with us. It is much appreciated. So Scott, Mark, and John, thank you again. Have a great day and enjoy the rest of your week. We're almost at the weekend.
Thank you very much.
Thank you.
Great. Thanks a lot.
Yep.
Take care, everybody. Bye for now.
Bye.